Okay, now we go on to the hard part, the resistance in a fluid, as well as Bernoulli's principle, which kind of puts all of this stuff together and says, okay, here's the fun things that we can do. Specifically, we can fly, which is very cool. All right, so concept 16 says, identify and explain sources of resistance for water moving through a pipe. Now you only have to worry about water moving through a pipe, so that's what you have to think about when you're doing this. So, back to our little study guide here. And again, I went onto a different page so that I have enough space here. We are talking about our fluid resistance now, specifically water in a pipe. Okay? And what we are going to talk about is what things change it. And we talked about this when we were going over the actual review. There are two things that it depends upon. One being the size, the other being the shape. We just talked about how the velocity was going to be affected. All right, so when you have more resistance, actually, let's define the word resistance. The definition of resistance is slowing the flow. And remember, this can be water and fluids, but it also can be, and this goes back to our electricity stuff, it can also be electric flow, so electric current. And it actually works the same way. So when you take a look at electricity, the size of the wire actually matters. Larger wires and larger pipes have less resistance because there's less area that you're rubbing against. The resistance is coming from friction. So it's slowing the flow through friction. And if you increase the amount of friction, you're going to increase the amount of resistance. So the flow will be even slower. Okay? That said, your size, larger pipes or wires have less resistance. Okay? And when you have less resistance, that means that the water can flow more smoothly. All right? So your size, larger pipes have less resistance. That means smaller pipes have more. Okay? The second thing is the shape. Sorry. That's supposed to be a colon. The shape of it. So when you take a look at it, anytime you have to turn, any turn will cause it to slow down as well. So that will increase the resistance. Turns cause resistance as well. So sharper turns, closer to 90 degrees, have more resistance. All right, some examples of this. I'm going to just write down what they are on your review. The big example for that is going to be numbers 6 and 7 on the review. And if you have not done that, you should go and take a look at it right now. If you have done it and you watched the last video in order to figure out how to do that, please make sure that you have a good understanding of why that happens. Okay? So